Para vocês que chegaram agora no canal, se inscreva e deixe seu like, muito importante. Também ative as notificações para receber todos os vídeos novos do canal, demorou? Então é isso, rapaziada. Bora pro vídeo que tá muito top.
You and you enjoy it, please feel free to subscribe. I'd really appreciate that. And also, I have a Discord server, so if you have absolutely any questions, go ahead and join that and shoot a message on the server. We're happy to help you. With all that boring shit out the way, we need to talk about how aimbot works. Now, in CSGO, we have view angles. This is an X, also known as pitch, and that constitutes your up and down. And you also have Y, which is your yaw, which is your left and right. Now, players in CSGO also have heads, believe it or not, and the head has a position. Now, your local player is also a player, which also has a head, which also has a position. These positions are relative to the center of the world. So imagine a line extending from the center of the world to the player's head, and imagine a line extending from the center of the world to my head. If we subtract these two vectors, we are left with a resultant vector that is from your local player to the enemy player. To accomplish aimbot, we're going to take that vector, we're going to convert it to an angle, and then we can write that angle to our current view angles, and that's going to result in our crosshair being placed on the enemy's head. Now, obviously, there's a lot more math, logic, and boring shit involved, but I hope that suffices as a simple overview for how aimbot works. With that out the way, let's hop into Visual Studio and start coding. Naturally, I'm going to begin by opening a brand new Visual Studio project. We're going to open an empty project, I'm going to save it to my desktop, and I'm going to call it aimbot. Now, first things first, you're going to come up to the top here and you're going to change from debug to release, and you're going to change from x64 to x86. Next, you're going to right click on your solution, go to properties, and make sure your C++ language standard is set to C++20. Next, you're going to come to advanced and you're going to change character set to use multi-byte character set. Go ahead and apply and you can exit out of that. Now we can start making the files for our cheat. The first file we're going to make is going to be our main.cpp file. This is going to be a source file, and this is going to be where our code is going to run. Next, we're going to make a memory.h file. This is going to hold our memory class, which is going to let us access the game's memory. The final file we're going to make is going to be a vector header file, which is going to hold our vector structure that we're going to make to help us work with vectors. Once you have all those files, hop into memory.h, we're going to grab our memory class. Go to the first link in the description below. This will take you to this GitHub repository. Go into cheat and go into memory.h. Go ahead and copy all of this crap and paste that into your memory.h file. This class is going to open a handle, get the process ID, and it's going to allow us to read and write process memory, which is obviously very important when we're cheating. Now we can go into our main.cpp and we can include that file. You should probably also include the vector file, and now we can go ahead and make our entry point. Now, as per usual, you're going to need some offsets. To get offsets, go to the second link in the description below, and you're going to go ahead and copy paste the offsets that you need. Here are the offsets that you're going to need. I have them in a namespace called offset, and I suggest you go ahead and pause the video, go and grab all the offsets and come back when you're done. Okay, now that you're back, you have your memory class, you have the offsets. The next thing we're going to need to do is make our vector structure. So let's get started on that. The first thing we're going to do is include the numbers header file. Next, we're going to create our vector structure. We create a struct, call it vector3. Now, a vector3 is essentially just 3 floats, so let's go ahead and put that in. Now, obviously, at the moment, these floats are uninitialized, so let's go ahead and make a constructor. This constructor is going to take 3 floats, x, y, and z, and it's going to set the vectors floats to those. Next, we're going to need to overload a bunch of operators. So this is going to be really annoying if you're typing this out. Now, if you don't know what operator overloading is, it's basically telling C++ how to work with our vector type that we made. We're overloading the subtract, the plus, the divide, and the times. So go ahead and pause the video and type this all out. Finally, we're going to make our toAngle function. This is the function that we're going to apply to our resultant vector that's going to give us the angle that we need to write. That function looks like so. I almost forgot, come to the top here and include the CMath header. And this is what the toAngle function looks like. We're returning a vector and we're using trigonometry over here to determine what the angle will be. And this part at the end here is us converting the degrees to radians. Next, we're going to make an is0 function to determine whether or not our vector has been changed. That function is pretty simple. It looks like this. Now, with all of that out of the way, we have a pretty cool looking vector structure. We're going to go back to main.cpp and we're going to create our calc_angle function. Calc_angle looks something like this. It takes our local position, it takes the enemy's position, it subtracts our local position from the enemy's position to get the resultant vector. We're going to convert that to an angle and we're going to subtract our view angles. This function is going to return the angles that you need to write to your view angles in order to put your crosshair on the enemy's head. We're going to use this function a little bit later, but for now we need to create our hack loop. We can do that like so. Now this loop is going to run 1 billion times per second, and that is really not necessary. So at the top here we're going to come and include the thread header. With the thread header included, we can now sleep this loop like so. Using std this thread sleep for blah blah blah. Okay, now before we do anything else in our while loop, we need to do a couple things. First of all, we need to initialize our memory class. You can do that like so. We're going to pass in csgo.exe as that is the name of the program that we want to access. Next, we're going to need to get the address of client and engine. You can do that like so. These two lines are going to store the address of client in a variable called client and the address of engine in a variable called engine using getModuleAddress. Okay, now we're going to bind our aimbot to a key, and we can do that like so. If exclamation get async key state and then whatever button you want, I'm using the right mouse button, but you can use whatever button you want. I'll have a link in the description below to the different key codes. So if you aren't pushing down whatever button you have here, we're going to continue the loop, which means we're going to skip and restart the loop. Next, we're going to need to get our local player and the team that our local player is on. We can do that like so. Getting our local player is as simple as reading a uint pointer off of client plus the local player offset, and getting our local player's team is basically the same thing except we're reading an int off of local player and the m_i team number offset. We're going to use local player for getting our local player position and all of that fun stuff, and we're going to use our local team to determine whether or not an entity is on our team when we decide which entities to aimbot at. Next, we're going to need to get our eye position. We can do that like so. Our eye position is going to be a vector 3, and this is going to be the position of our eyes in 3D space. We can get the position of our eyes by reading vec origin of player and adding the vec view offset of our local player. Remember, we overloaded the plus operator. This is so that we can add vectors, and this will give us our local eye position. Next, we're going to want to get our client state pointer. We can do that like so. Client state is going to be memory.read. We're going to read a uint pointer off of engine plus the DW client state offset. Now, using the client state offset, we can get our view angles like so. View angles once again is going to be a vector 3, and it's going to be client state plus DW client state view angles. And last but not least, for all of this reading shit is we're going to get our aim punch, and we can do that like so. Our aim punch is also going to be a vector 3, and it's going to be local player plus our m_aim punch angle offset. Now, very important here, we're timesing this by 2. If you haven't watched my RCS video, I suggest you go ahead and do that. I will have a link to that in the top right. Times this by 2 because that is the value that CSGO uses. I know, great explanation. Anyway, now we can actually get into the aimbot code. We're going to need to store 2 variables outside of our entity list loop. We're going to make those right now. This variable we have here that I have called best FOV is going to be the FOV of your aimbot, and best angle is going to be the best angle that we're going to write to. If you ever want to change the FOV of your aimbot, you're going to change this value right here. Anyway, now we can go ahead and loop through the entity list. We can do that like so. We're going to create a good old trusty for loop. It's going to start at 1 while the index is smaller than or equal to 32. We're going to increment I. Let's get the player. Getting the player is as simple as reading the memory as a uint pointer of client plus the entity list plus the index of our for loop multiplied by the size of the entity object. Now we're going to perform a series of entity checks to see if we want to aim at this entity or not. The first check we're going to do is to see whether or not they are on our team. We can do that like so. Remember, up at the top we got our local team. Well, this is where that comes in handy. We're going to read the enemy's team number, and if they are equal, we're going to skip them. This is so that we filter out all of our teammates out of our aimbot. Next, we're going to check if the entity is dormant. We can do that like so. Very important, we're going to read a bool off of the player plus the dormant offset, and if they are dormant, we're going to skip them because we don't want to be aiming at dormant entities. Next, we need to make sure if the player is alive. We can do that like so. Essentially, if the M health offset is 0, that means that their health is 0, which means that they're dead and we don't want to aim at them. So we're going to go ahead and continue. The final check we're going to make is going to be whether or not they're spotted, right? Because we don't really want to be aiming at people through walls. So we can do that like so. We're going to read a bool off of the MB spotted by mask offset. And if they aren't spotted, we're going to go ahead and skip them. Okay, with all those annoying checks out the way, we're going to go ahead and get the entity's bone matrix. This is so that we can get their head position. You can do that like so. The bone matrix is a uint pointer off of the player plus the DW bone matrix offset. Now, using the bone matrix, we can get the player's head in 3D space, just like this. We're going to construct a vector 3, and we're calling it player head position. This is going to use the bone matrix plus 0x30 times the index of the bone. This number over here, 8, is the head bone index. This here is going to return the position of the player head in 3D space. Now we can go ahead and calculate the angle. That's going to be done like so. We're going to call our calculate angle function, and the position we're going to pass in is going to be our local eye position. The entity's position that we're going to pass in is going to be the player's head position, and the view angles we're going to pass in are going to be our view angles that we got up at the top over here plus aim punch. Remember, this is times by 2. This means that we're going to be aimbotting and basically building in RCS. Now, using that generated angle, we're going to go ahead and get the FOV. The FOV is pretty simple. It's basically the hypotenuse of our view angles. And last but not least, to complete our entity check, we're going to compare whether this FOV is smaller than our best FOV, and if it is, we can then set the best angle to our current angle. That's going to be done like so. Just to give a quick overview of what this code is doing again, here we're setting our aimbot key. This is all commented pretty well, so you can figure out what this does by yourself. But in this loop here, we are looping through the entity list. We are checking that the player is someone who we would want to aim at. We're then getting their position. We're then getting the angle between them and us. We're then checking the FOV, and if the FOV is smaller than the best FOV, we're setting the best FOV to our FOV. This means that this is going to loop through the entity list, and it's going to get the best angle to aim at for the best entity. I really don't know if that makes sense, but we'll see. Now, after all of that's been done, if we have found an entity within our FOV that is an enemy, that is spotted, and that is alive, we can now do our aimbot. And that's going to be done like so. We're going to check if !best angle is 0. This means that we actually did find an entity to aim at. And if that is the case, then we're going to write a vector 3 to client state plus our client state view angles. And what we're going to write is our view angles plus the best angle that we made over here. Now, over here, this is going to be the smoothing of your aimbot, right? The more you divide it by, the more smooth your aimbot's going to be. If you want absolutely blatant aimbot, then you should just get rid of this divide by a float. But if you want smooth aimbot, then that's going to change with this number over here. Anyway, that should be our aimbot done. So I'm going to go ahead and build this. All right, my build has succeeded. I'll catch you guys in game. Alright, so I've just loaded into game. I'm going to go ahead and run aimbot.exe, and if I aim near a player's head, it automatically locks onto them. If that's too blatant for you, once again, increase the smoothing factor and mess around with the FOV and, you know, customize it to your liking. Anyway, with all of that shit out the way, hopefully you got a working aimbot out of this. Because this is a lot of code and it's a lot to follow, I'm going to upload this to GitHub, so if you need a reference, go ahead and look at the GitHub in the description below. I really hope you enjoyed the video. Remember to like and subscribe and join my Discord server.